We're good.
Yep,
Hello.
we're here. Hey, folks.
Hey, folks. We will just give it a moment or two while everybody joins. But welcome to the webinar. Let us know where you're from in the chat so we understand where you're joining from. And we'll get started in just a moment or so.
I'm really intrigued. I love this in webinars, finding out where everyone's joining from, because I think that people are so spread out and you never know where's the furthest someone's going to be.
Indeed. Maybe you can speak to yourself, J-Law. Where are you from?
Well, yes, that's very true. Let me pop myself in the chat as well.
Dundee.
Dundee, South
Hey,
Africa.
Clinton.
Cool. Hey, Clinton.
Great stuff.
Hey, Aaron.
Hey, Aaron. Very distributed group of people joining, which is great to see. Maybe we can do a quick intro then while the last few people are joining. So thank you very much for joining today. I'm James. I'm Director of Product at Conduktor. Today we'll be obviously talking about the subject at hand, which is building trust in your real-time data, be it for AI or for your just distributed systems. Very fortunate to have Jonathan with us today. So over to you, Jonathan, to introduce yourself.
Yeah, sure, James. Thank you. Hi, folks. I'm Jonathan. I'm a product manager here at Conduktor, looking after, surprise, surprise, trust itself.
Good stuff. Right. I think we should get into it. So throughout the session, feel free to pop any questions you have in the chat. I think you can react, emojis, all sorts of things inside Livestorm. So don't hesitate to do that. If we can answer the questions while we're going, we will. Else we'll come back to them at the end. Great stuff. So brief look at the agenda. We're going to talk about the cost of bad data. Very excited to expose our latest product, Conduktor Trust, of which Jonathan is the product manager for. So he's going to do us an introduction to that. He's going to tell us how it works, and we're going to do a live demo. Pray the demo gods are kind to us.
Fingers crossed.
If you're not familiar with Conduktor, quick intro. So at Conduktor, our vision is to connect the right people to the right data at the right time. That's the number one problem that we're solving. Obviously, having access to the right data is what helps organizations gain insights and drive business decisions. And specifically today, we're going to talk about the cost of poor data quality. So a bit of context on common challenges. This is lifted directly from the 2025 data streaming report, which Confluent published this week. If you haven't seen that, I would highly encourage you to go and check it out. Some super interesting insights, and you can see here, this is from about interviewing around 4,000 IT leaders. And you can see here a couple of trends. 68% mentioned that inconsistency of data sources is a frequent challenge. That's also a little bit tied to 67% who cite uncertain timeliness or quality as a hurdle to decision making. Equally, the annual State of Data Quality Survey, they highlighted that it takes roughly on average about 4 hours or more to detect data instances. So as you can see, there's a substantial issue here with the timeliness, data quality monitoring. We know this is an issue that impacts all businesses. Maybe the question is, why is it more significant now as opposed to the last decade? Data quality issues have been around forever. So let's dive into that. What's driving this? Well, the uptick in agentic and generative AI systems is obviously driving a lot of organizations to shift left. Hopefully everybody's heard this paradigm now. It's not new, but what it's all about is about moving that processing, moving the governance of data much closer to the source. And if you think about distributed systems, event-driven architectures in general, the cost of bad data at source has substantial knock-on effects, right, throughout that system, right, because consequential actions are happening within that system. You may be familiar with this paradigm, the 1-10-100 rule. It's the idea that it costs you $1 to detect and fix an issue at the initial stage, 10 at the transformation stage, and 100 at the consumption stage. So things get progressively more expensive. There's a great insight about Unity Technologies. I think a couple of years ago, maybe 2022, they lost around 100 million in revenue after ingesting bad data from a big customer, corrupting their advertising platforms, ML models. So super, impactful issues. Our CPO actually coined this new phrase. You've probably heard garbage in, garbage out. He promotes garbage in, disaster out now as a result of the fact that in agentic and AI systems, the cost of bad data quality is actually much, much worse. That's because you're potentially fueling, customer experience, real-time decisioning, and therefore that has real-world consequences, right? Breaching policies, compliance nightmares, and all of that has a negative effect in terms of customer trust of your application. So maybe to dig into that a little bit more on this next slide. Obviously, in generative AI, bad inputs can impact your decision making, and the response. Whereas in agentic system, autonomous machines taking decisions, bad data can really turn into a disaster in terms of a wrong diagnosis, somebody being declined a mortgage, depending on what the domain and the use case is. So if we dig into some common data quality issues, let's talk about inaccurate metadata, missing timestamps. That can break temporal context in streaming agent systems. That means broken automation workflows, missed SLAs, missing schemas, right? Inconsistent formats of data fields. That can break prompt inputs and retrieval chains. That can lead to output failures, slow adoption across teams. You have duplicate records. What's that going to do? That's going to inflate signal strength. That's going to reinforce biases. All of those can have a super negative effect on eventual customer experience, can increase your risk, increase your exposure. Missing data in general, right? That can lead Gen AI models to hallucinate. Probably everyone's seen some examples of this, having to kind of use false information or estimate information. That can have a chance of increasing churn and risk compliance as well. And out of range values, right? That can throw off model logic as well. That can cause erratic behavior and decisions that break trust with users and systems. So all of these things, right? They're not new. We've seen them before over the last 20 years in data systems, but the consequences based on what's happening in the market now can be significantly larger. So with that in mind, let's have a quick deep dive into, a general architecture describing how quality is kind of generally approached today. In this case, we've got Kafka as our kind of integration backbone, and then all of that data being offloaded into our, in this case, Medallion architecture through Airflow, through Spark, Fivetran, one of those integration systems. That lands your raw data in that bronze layer or bronze tier. And then between the bronze and silver, you might have some cleansing, some curation, some validation happening. That could be proprietary code, right? It could be tools like dbt, Great Expectations, or other third-party vendors that are running periodic SQL queries against the data. Regardless of how this is happening, this means the data is being evaluated kind of on a periodic cycle or at certain points in the day. Potentially decisions are being made on stale data. And if we think back to that paradigm of the 1-10-100 rule, that data is already landed, right? And therefore the consequence of having to work back upstream to fix it is more expensive. So I'm going to hand over to Jayla in a moment, and we're going to then look about, how we can kind of shift away from this architecture that we've been using for so many years into something new.
Yeah, definitely. Thank you, James. So let's talk a little bit about Conductor Trust and how we're approaching this perhaps a little bit differently. So with Conductor Trust, one of the main paradigms that we've been trying to focus on is ultimately building trustable data products. So we all know whether you're choosing to sell that data, if you're choosing to use something like Conductor Exchange, or you're wanting to use that data in-house, you need to actually trust the data that you're producing. Having confidence, obviously James referenced Unity before. This is one of those things of, hey, actually, if we set out some guardrails, if we set out some rules, we can make it a little bit more sensible what we're trying to do. Elevating visibility to the central team to make sure that they know, hey, this is what is going on, making those unknowns known instead. And ultimately, doing the 1-10-100 rule, fixing earlier means that you don't have to wait until it gets very expensive to fix. So kind of the big picture, the big statement item that we're trying to use and think about when it comes to Conductor Trust is really you can build and govern once and then use that data anywhere. And when we take a look then at the picture, kind of the difference between the reactive approach and this proactive approach, we can see that using Conductor Trust allows you to secure and have high quality data in stream, and that data then can land directly into the silver tier. That means that the data itself is already protected and you can be more confident in the data that is landing. Does that make sense, James?
It makes perfect sense. The question I would have for you is, one of the approaches to this that's been quite popularized in recent years is this sort of schema-based data contracts approach. So I'm curious how you see this as, whether you see it as the same as that or whether you see it as something slightly different.
Yeah, that's a great question. So to me, it is somewhat different, primarily because with a schema-driven approach, which we all probably think is a great way of doing it, that's fantastic when you're starting something new. But it is pushing all of the responsibility down to the producer. It means that they have to enforce the contracts at that point in time. And really, that's something that is quite expensive to do, whether it's rebuilding a system or having something kind of there from the get-go. It's not as easy as kind of just dropping in to something like our Kafka system and having trustable data from the get-go.
Makes sense. And just to double down here, you're basically saying the consequence of enforcing this quality or governance at the streaming layer, right? When the data is actually incepted or written, is your ML models can actually feed directly from that data, knowing that it's trustable, right? It's already gone through that layer of approval from your business that says this is what a good payload of data looks like.
Yeah, exactly. So it enables you to act more correctly in terms of more real time. And that's what everyone wants, right? They want to act more correctly, more current.
Sounds good. Let's see some more.
Sure. So let's talk a little bit about how it works today. So we've kind of formed this anatomy of a data quality check that we're using to be, hey, this is how Conductor Trust will actually operate. First, we have rules, which is how the data itself will actually be validated. And typically, the people that know the data, that's your people like your product teams, your application teams who know the data that they're sending. And then you know where you want to validate your rule. So that's your policy. Where do you actually want to apply the rule? And then your action. What do you want to happen when the violation occurs? Assuming violations undoubtedly will occur. And this is one of those things that the data team, the governance team, the central platform team may be interested in enforcing. They may want to go as far as saying, hey, let's just not let the data in if it's bad. Or maybe they want to take a more relaxed approach and say, hey, let the data in, but we just want to know. And then obviously in the final stage, insight, we want to say, hey, what's actually happened and truly make the unknowns known. So if we dive a little bit more in, how does it actually fit together? How do these pieces of the puzzle all fit together? So ultimately, we have the policy, and the policy dictates where do we want to check? What do we want to validate the data? And you can do either specific topics or you can do prefixes. And then when violations occur, what do you want to do? Right now, we focused on either end of the spectrum. So you can report that something's went wrong, or you can go full nuclear and say, hey, I want to actually block that data. In the future, we're thinking about things like enrichment, so adding headers, or sending messages to the dead letter queue for further enhancement and further investigation.
Maybe we can dig into those 2 points in the future section as well. So enrichment, you're saying you could evaluate a message, add some headers that say, or give it a quality score, or say that this has failed a violation, and that would basically give your applications the ability to determine how they want to behave, right, based on reading that header.
Yeah, exactly. So you have the ability then to allow your applications that are consuming the data to make that decision instead of right now. just having to take the bad data and run with it.
Makes sense.
So let's look at the other side. This is policies and actions. Let's look a little bit at rules. So with rules, there are a couple of different rules you may want to enforce. All of our rules are built using the common expression language. And this means that you can build easily understandable, fairly parsable language to say, hey, these are the things that I want to check. So, for example, you may want to validate mandatory data, so things like IDs or values. You may want to ensure that headers are there for compliance reasons. So, things like, hey, this data has a given classification. Or even enforce things like the actual data format itself. Hey, this data is average. So that's a lot of talking. Let's actually have a little look at Conductor Trust. Let's have a look at what is happening, if I can go the right way. So obviously this is Conductor Console, which hopefully folks are somewhat familiar with. If not, you can go to the website and get started today. You can go out and play with it. But let's take a look at setting up some rules and setting up some policies. So rules, as mentioned, are pretty straightforward. They're quite simple. They are common expression language, and here you'll see that I've got four. I've got one validating the user has either no newsletter preference, or if they do have a newsletter preference, they've got a preferred language. That their email address looks like an email address. They have an age, and that age is valid, and then the data always has a data classification. And then finally, we have a conductor rule that enforces Avro. If we take a look at policies, we have a single policy here. And this policy is enforcing all of our rules at once. We want to say, hey, if anything is wrong with any of these rules, we want to go to the furthest extreme and we want to block that data. And in this case here, you can see that there's examples of me testing it earlier. There have already been 2 violations. So let's go to topics and let's go and have a look at how this actually manifests. If we produce, and it's worth noting, this is production of a message from wherever it comes from. We're going to use Conductor Console here to make it easier to show and demonstrate. If we produce a message and we look at one of my examples here that I've got stored, and we try to produce this invalid record, invalid header, you can see there's a couple of problems already. The age isn't valid. No one is 333 years old. At
Are
least
you
I
sure?
don't think so. I'm pretty sure. I'm pretty sure no one has reached that grand old age yet. And the email address is definitely not an email address. It's a website, right? So there's 2 problems. And well, that is not a data classification. So if we try to produce this message via Conductor Console, you'll see that the message gets rejected. And if we go back to the policy, you'll see that it was rejected for every reason that we've just highlighted: the age, the email, the data classification, and we'll go back there in a sec to look. So let's try again. Okay, we're going to fix that data. We've noticed that, okay, that's one problem. Let's fix the content of the message, but we've still not fixed the header. If we produce this one now, that still fails. So the header is wrong, but the rest of the content is correct. So that one still fails. Let's go for another one. Okay, let's try and get this a little bit more right. Let's go for this one. Okay, right. Data classification is now C2. That's perfect. Let's produce. Oh, wait, no, I went back to. Oh, crap. I went back to the wrong message. I needed to use the correct message. Okay, let's go for this one. Valid record, invalid ID. In fact, you know what? Let's just go all the way to valid. Valid record, valid header. Perfect. So the age is 33. There is an email address, and it actually has the data classification. Let's produce this one. Okay, cool. This moved into the right-hand side, so this has now successfully produced. So let's jump back to policies and take a quick look at what's happened. So we go back into policies here, and you can now see there's a lot more evaluations and a lot more violations. In that case, you can see this one where we've broken the email rule, the age rule, and the classification rule. One where we just broke the classification rule, but we had a good body. and then one where we broke the age rule and we broke the email rule, but we had a valid header. Let's set up another rule just to see how that looks. So there's something missing in my mind. I don't know about you, James, but I think there's an ID missing. I would like to see an ID for my user. I think that without that, it's, for me, a UID is always a good thing to have. I don't know if anyone else feels that way about UIDs, but I like them. I think they're useful. So let's set up this rule. We're going to call this our UUID rule. It validates the user's ID. And we pop in our cell, which I've helpfully copied from elsewhere, and we'll create that. So now we have a new rule in our system. If we go back to policies, we can set that rule in a policy. So let's create a new policy. Let's say this is the UUID policy.
So just to be clear here, what you're saying, Gilo, is the rule is essentially the data rule, right, on the piece of data that you want to run that rule against, but the policy ties it or binds it to a target, right? It binds it to an actual a topic or a set of topics or a prefix, like you described earlier.
Yeah, exactly. So the rules do nothing on their own. The rules are just, hey, this is the general shape of the data, how it should operate. And then in setting a policy, you're saying, hey, this is what I want to happen on these specific topics that I have. So here, let's choose UUID rule. And then let's set this up against our gateway. We have one gateway set up. And in this case, we have the topic I'm using, which is customer transaction. So we're setting up against Conduktor gateway and the single topic, so not the prefix, customer transaction. And here you'll see, okay, this is the policy that I want to set. I want to set a UUID rule against the customer transaction topic. Let's hit create. So in this case, you'll see now that no actions happen by default, which is probably the right way to go. I'd hope you'd agree, James. We don't want to block any data that may be bad. We just want to know about it. We want to know about the violations and say, hey, this looks a bit, we're not super sure. And it's worth noting in the rules section, we can define looking at both the body, the key, and looking at the headers of a message. So we can evaluate to see, hey, is there consistency? Is there things that are wrong? So now that we've set up this policy, checking the customer.id, let's go back and try to produce. Again, remember, this is on customer transaction, which is the same as this previous policy here, looking at customer transaction as well.
We had a question as well from Jose Manuel around whether you can show the error that the Kafka client gets when the rule is violated. I don't know if you can show that here, if you have a Kafka client to hand, or whether you can expand on it.
I can show you. You basically get a message back. So if we jump into this, you'll see that my lovely iTunes that I've been listening to. But you'll see here that in the actual failure, we get an invalid record exception back, saying that the validation has failed on the broker and the message will be rejected. So in this case, this red part at the bottom here is extra help per text for us. But you'll see that, hey, we've said, hey, the message is invalid and cannot be processed. It's worth noting we're always looking at improving this, and it is something that we are, hey, we know that you need more information, but it's important to remember.
Yeah,
exactly. It's important to note that we do know in the case of in the trust user interface why that has happened. So if we jump back in here, you'll see again these have this particular produced message here failed because all of these rules were violated. It wasn't just one of the rules.
makes sense.
So let's produce this message now. So again, we were doing customer.id, and if we go back to the topic and go back to my helpful customer transaction topic and try to produce, now this is real praying to the demo gods. If we try to produce this one, which is almost totally correct, right? You can see it looks perfect. It's got the ID, but that looks maybe, I don't think you get a Z in a UID, but let's just see. And I think this might work. It did. Perfect. Oh, great. Right. Webinar over. We're done, right? It worked. Well, let's take a minute though. Let's go back and look at my policy that I've set up. Okay. So I said if the customer.id.matches a UID, I just want to count it. It's worth noting counts take a little bit longer because of Prometheus and the metrics. If we turn on report now as well and go back into the console and produce this message one more time, we should see back here that, oh, we broke the rule. Oh, be- because I had the Z character. Okay, that's my bad. Let's go back and say valid record, valid ID. This is correct. Oh yeah, okay. It was supposed to be an F, not a Z. That's my bad. If we produce that, okay, that's now successful, and you'll see that it has been successful and is not reported back here. So this is all the failures that have occurred when actually I produced invalid messages, invalid crap, essentially. They didn't have the correct stuff on them. So let me jump back to here. I see there's another question from Sarav as well.
There is, yes, whether we can create a rule to tag a PII field for field level encryption via gateway.
Yeah, so I think the question there is really, do we want the PII field to be flagged if it's if it's not encrypted? That would be exactly something you could say in Trust. You could say, hey, if this field looks like a digit number, for example, then it means it hasn't been encrypted, and that's an alert, right? That's something you need to know about.
I also going to ask you a question because we focused on Avro in your demo, but
Yes.
How are you thinking about Proto and JSON?
Yeah, definitely.
People without schemas.
Yeah, that's a great point. So we did focus on Avro in the demo there. And if we jump back to this screen again, back into policies. Oh, sorry, not back into policies, back into topics, and look at the produce, you'll see that it was using Avro. So it was saying, hey, this message has to be Avro. If we say, okay, let's do JSON, right? Let's say JSON, we'll use the helpful generate once. This is going to break every rule imaginable, right? Because this is not what the message looked like. We need to say, hey, okay, but maybe you are using JSON. So we're looking to introduce the ability to do protobuf. We're looking for the ability to introduce JSON, but it's also super important to note that this is not dependent upon a schema being in place on the record or on the topic. This is an example. Obviously, we are using an Avro format here. We are using a schema, but these checks can be done without a schema being in play.
And the last one from me is you've shown everything steered via the UI today, but assuming that you can create these resources, these rules, and these policies via the CLI as well.
Yeah, correct. You can indeed. So helpfully, the question from Sarav around, what comes back in the CLI. This was all done and set up via the CLI. You can create policies and rules via the CLI. And the same thing applies for obviously creating messages. This is what you get back when you send erroneous data.
Awesome.
So I'm aware we're nearly out of time. Preview is available now. People can get started. If you want to talk to us, obviously head to Conduktor.io. You can take a look at Trust. There is a landing page, Conduktor.io/Trust. If you want to look at Trust specifically, book a call with us. We are more than happy to share and talk to you about this. And when we're thinking about Trust a little bit bigger, when we're thinking about general availability, we are thinking about this launching in July time with extra features such as the ability to templatize rules, the additional actions, so big things like enrichment and DLQ. I know, James, you were asking about that before.
We've
So
also got a question in the chat about does
I
it
I
allow?
I know, I seen it. I seen it. So the additional actions, the DLQing, rerouting to the DLQ is super important for us. And one of the big things that we're looking to do there is, hey, do you want to block the message as we've already implemented from going to the original topic, or do you want it to get just a copy sent to the DLQ? So that's something that we're looking at right now, is the ability to send messages to the DLQ to say, hey, this needs further inspection. We need to look at this a bit more. So it's important to know that the data is kind of leading us down this route of the DLQ kind of coming next. We're thinking about that one next. Enrichment, so your consumers and producers can make decisions off of headers, is also coming soon. There is also the testing of data. I do see another part of your question, Bonnie. So you said when a bad record is blocked from coming into the topic, does it error out on the logs on the Conductor gateway side or the producer app side? Both. You'll get a message on the Conductor gateway side saying why it was blocked. And on the producer side, it will be told, hey, this has failed validation on the broker and thus cannot be produced. And that is really a super duper quick dive into Conductor Trust. Is there any other questions? Anything else you'd like to ask, James?
Looks like we have one. Very good question. The functionality depends completely on the gateway, right? That is our Kafka proxy, if you're not familiar with it. Jose Manuel says he's almost 100% sure the answer is yes, but can you clarify?
Yep, I can clarify, and you will give you the 100%, Jose. You are correct. It does depend upon the gateway. The gateway is the important part of the puzzle here for getting ahead of those messages before they land in on the Kafka broker. So one of the things we didn't speak about on this slide here is we're talking about consumption as well, potentially. Consumption is one of the things of, hey, the bad data is already there. How do we handle that case? And that's something else that we're looking at is, hey, we're talking about production right here. But then also, what about consumption? What if the bad data is already there? Is there something we can do to help with consumption? So yes, you are totally correct. It relies entirely upon Conductor Gateway.
Okay. If there's any last questions, I think it looks like we might have one typing, so maybe we can pause for one last one. Thank you for the demo, Jonathan. Demo gods were kind.
They were kind. I'm very glad.
And as mentioned, this is in preview, so please do get in touch if you want to be early adopters. Right, one last point here. Jose Manuel, yes, they're using schema registry extensively, but there's no enforcement. Even the usage of schemas is open for each team's decision. I think that's something we see a lot of all of the organizations that we work with. The assumption is you should be using schemas. That's rarely the reality across the entire organization. And I think you kind of picked on it earlier, Jonathan, that this is a system you could implement over environments where you are using a schema, and also the schemaless cases as well, which once they're in production are hard to remove.
Yeah, exactly that. I think that part of the problem really is knowing what you don't know and having the visibility and the way to see, hey, what is actually going on behind the covers of this system. So exactly that. With schema registry, with the ability to have schema enforcement, I think everybody would hope that they could do this. However, we know that the reality is a little bit more murky than that. And unfortunately, that does mean there is a lot of unknown data floating through the system. And Conductor Trust allows you to see into this is what's actually going on and get you enabled to make decisions as well of the bad data.
Brilliant. Well, I think that just about wraps us up for today, but thank you very much, Jonathan. And I can see that, Katrina, you've just gone back to Clinton, which is much appreciated. Thank you, everyone, for joining. As I said, please do get in touch if you want to talk about next steps and getting your hands on this product. Otherwise, have a nice afternoon and evening. Thank you, everyone.
Yeah, thank you, folks.